Good day everybody. We got a beautiful Olympiad question. The question is as follows. If x is equal to cos 1 degree, cos 2 degrees, cos 3 and so on and so forth up until cos 89 degrees, and y is cos 2 degrees, cos 6 degree, cos 10 degree and so on and so forth up until cos 86 degrees, then find the closest integer to 2/7 log of y/x to the base 2. So you are given 4 choices. Is it 13? Is it 15? Is it 17? Is it 19? You can pause the video and try the question. You are actually expected to find the closest integer to this quantity. So let me give you the answer. You can check the solution with the ones that you have done against the one that I have shown you here. Now, foremost, I would like to calculate y/x. This is important. Now, for that, let me outrightly consider x. X is given to be this: cos 1 degrees, cos 2 degrees, cos 3 degrees. This is actually cos 3 degrees, cos 4 degrees, and so on. It goes all the way up until cos 89. Now what I wish to do is I would like to stretch all the way to cos 45 degrees, and then you have on the left of cos 45 you got cos 44, you got cos 45, and then you got cos 46 degrees, cos 47 degrees, and so on. It goes up to cos 89 degrees. Now cos 45 we know 1/√2. So what I wish to do, I would like to rewrite this as 1/√2 times cos 1, cos 2, cos 3 up until cos 44, and then you got cos 46, cos 47 up until cos 89. Now cos 89, what is cos 89? Cos 89 is actually cos of 90 minus 1. Now this is similar to cos of 90 minus theta, which is nothing but sine theta. So cos of 90 minus 1 is going to be sine 1. Now similarly, this is for cos 89, right? Similarly, if you were to consider cos 88, because the degrees are cos 1, 2, 3, 4, 5, 6, go on, it goes on all the way up to 89. So the degree before 89 is going to be cos 88. So cos 88 is going to be sine 2, because cos 89 is sine 1, cos 88 is sine 2, and cos 87 is going to be equal to sine 3. And if we were to go up all the way, pushing the values all the way to cos 46, now what is cos 46 is going to be? Now cos 46 is nothing but cos of 90 minus 44, which is nothing but sine 44, right? So if I were to start here replacing cos 89 by sine 1, this is going to be sine 2, this is going to be sine 3, and all the way it would reach sine 44. That's exactly what I'm trying to explain here. All this has happened because of this formula: cos of 90 minus theta is equal to sine theta. Now what I wish to do is I would like to club cos 1 with sine 1, cos 2 with sine 2, cos 3 with sine 3, and so on and so forth. So if I were to do that, this is going to be equal to 1/√2. So let me write this as sine 1 cos 1, and sine 2 cos 2, sine 3 cos 3, and it goes all the way up to sine 44 times cos 44. So clearly we can see that there are 44 terms here. Now what I wish to do is I would like to multiply this by 2 and divide by 2. So multiply this by 2, divide by 2, multiply this by 2, divide by 2, and so on and so forth. So altogether we would be having 1 over 2 raised to the power of 44 terms, because every time I multiply I need to divide. Now this can be rewritten as 1 over 2 raised to the power of 44, and you got a root 2. I can rewrite this as 2 raised to the power of 44.5, and 2 times sine 1 cos 1, what is that? We can use the formula 2 times sine theta cos theta is equal to sine 2 theta. Right, so by that formula this is going to be sine 2 times 1, which is sine 2, and this is going to be sine 4, this is going to be sine 6, and sine 8, and all the way up to sine 88. This is what I've got. Now again, what I wish to do is I would like to rewrite sine 88. Now what is sine 88? Sine 88 is nothing but sine of 90 minus 2. Now there is a formula. Sine of 90 minus theta is equal to cos theta. So in this case this is going to be equal to cos 2. Now if I were to reduce the terms, or I should say moving up like that, replacing all sine 88, or I should say all sine angles with cos, then for every quantity that you see here, sine 2, I would have a corresponding pair as cos 2. Sine 4, I would have a corresponding pair as cos 4. So let me show you that. This is going to be equal to 2 raised to the power of 44.5. For sine 88, it's going to be cos 2. Now the next term is actually going to be cos 4, and subsequent term, the next term is going to be cos 6, and so on and so forth. So in this case it's going to be sine 2 and sine 4 and sine 6 and so on. So what we can do is we can club these terms. So if I were to club the terms, I would have 1 over 2 raised to the power of 44.5 times, it's going to be sine 2 cos 2 sine 4 cos 4 sine 6 cos 6, and all the way to sine 44 times cos 44. So this is what we would have. Now I would like to multiply by 2 and divide by 2, multiply by 2, divide by 2, multiply by 2, divide by 2, multiply by 2, divide by 2. So in all there are 22 terms. So this is going to be 1 over 2 raised to the power of 22. So this can be rewritten as 1 over, let me write that, 1 over 2 raised to the power of 66.5 times 2 times sine 2 cos 2, that's going to be sine 2 theta, so it's going to be sine 4, and this is going to be sine 8, this is going to be 2 times, that's going to be sine 12, and followed by sine 16, so 4, 4, 4 and sine 16, and this is going to be sine 88 finally. So if I were to write sine 88 as sine of 90 minus 2, this is going to be cos of 2, but if you were to see the value of y given, y is given to be as cos 2, cos 6, cos 10, so on up to cos 86 degrees, right? Now cos 2 is obtained here from the last term. Sine 88 is nothing but cos 2. Now if you were to move further, say sine 84, sine 84 is going to be sine of 90 minus, to get 84 I subtract 6. So this is going to be equal to cos of 6 degrees. So cos 2 is got, cos 6 is got. You can see that the first term is there, the second term is there. And similarly, if you were to move up to sine 4, all the way to sine 4. Say, what is sine 4? Sine 4 is nothing but sine of 90 minus 86, which is nothing but cos 86 degrees. So cos 86 degree is the last term. So clearly we have got that. Now consider sine 8. Sine 8 would produce the second last term, and so on and so forth. So clearly you can see that all of the terms of y would be cancelled by the terms in x. So therefore, if you were to find out y over x, this is equal to, my x term is going to be 1 over 2 raised to the power of 66.5. That's my x, and the terms are sine 4, sine 8, etc. up to sine 88, and my y term is going to be cos 2, cos 6, etc. cos 86, right? So as I mentioned to you, cos 2 and sine 88, they get cancelled. Similarly, the terms will get cancelled, and finally cos 86 will get cancelled with sine 4. So this is equal to 2 raised to the power of 66.5. This is what we get, y over x. But we don't need just y over x. We need 2 over 7 log of y over x to the base 2. So this is equal to 2 over 7 log to the base 2 of y over x is going to be 2 raised to the power of 66.5, right? That's what we have got. So if I were to use this formula, since log of a raised to the power of b is equal to b times log a, this is going to be 2 over 7 times 66.5 times log 2 to the base 2. Now since log a to the base a is equal to 1, this is going to be 1, which would give us 2 times of 66.5 divided by 7, which is equal to 2 5s are 10, 1, 6 2s are 12, 13, 1, 6 2s are 12, and 13. This is what we have got, y over x. And this has to be divided by 7. So it's 133 by 7. This is the outcome. So if I were to divide 133 by 7, 7 divides here 1 time, 63 times, I should say I got 63, and 7 divides 63 9 times. So the solution is 19. This is the right choice for this question. So if you would have picked 19 as the choice, then you score. Thank you everybody, enjoy your night.